Good morning, sir.
Good morning.
We are waiting for some members and we will begin shortly.
Okay.
Good morning, everyone. I am Sanskriti Kumari, a student at HIT Haldia, and I'm pursuing BTech in CSC AIML, and I'm also a member at AIML Club HIT. I am thrilled to host our very first session of Tech Talk. I would like to welcome the participants, the students, and our very honorable speaker for the today's session. It is my absolute honor to welcome our respected guest speaker, Dr. SARABJOT Singh Anand, co-founder of SABOT Foundation and Tartarus. Let us have a short introduction about our speaker today. First, with 30 plus years of experience in data science, Dr. Anand has been contributing to the field of machine learning since the early 1990s, developing algorithms, applying them to real world problems, and training generations of data scientists. He has completed his PhD in machine learning in 2000s, and as an academic, he has published over 90 research papers during his tenure as associate professor at the University of Warwick. His first startup in Ireland won the European IST Grand Prize and several other technology awards. In 2018, he co founded the Support Foundations that trains engineering students in machine learning and data science, solving social problems in areas such as education and healthcare. Today, the foundation empowers around 700 plus students every year, completely free of cost. We are truly honored to have you with us today, sir, and I would like to invite you to share your wisdom, knowledge, experiences of your journey to the students of HIT. Over to you, sir.
Thank you, Sanskriti, and thank you for inviting me. It's always a pleasure to interact with young minds, and I look forward to the interaction. I'll share my screen. What I'm going to do is give a little bit of an introduction into how machine learning works. And machine learning, as you know, is the foundation for what we know as artificial intelligence, and really talk about how this new wave of artificial intelligence is changing the role of humans in participating within the world economy, right? So if we look at the last 15 years or so, it comes as quite a surprise to folks like us that have been working in this space for a long time. But there is a lot of media coverage on AI, right? There are billions of dollars being invested. There's all sorts of talk of AI potentially destroying all jobs, destroying humanity. And it's quite a confusing time for young people like you who are just about training to get into the workforce, right? And here is an example of one person who's already lost his job. He is the world champion of a game called Go, which is a strategy game, much more complex than chess. But even a few years ago, AI was able to beat them. This was specifically an AI called AlphaGo that was developed by Google's DeepMind in the United Kingdom. Again, a few years ago, there were a lot of AI researchers themselves and thought leaders that were looking at trying to make the world aware of the dangers of AI. And this is a screenshot from a movie they had created called SLAUGHTERBOT. So if you want to see the full movie, you can do that by putting in SLAUGHTERBOTs into YouTube. And it's quite a terrifying movie, right? Because this person here is an arms dealer, and he's talking at this stage where they buy and sell weapons about this new weapon that's been created, a small drone that can sit on the palm of a human. And it can do face recognition while traveling at high speeds, moving in random directions to make sure that it can't be shot down. It lands on the forehead of its target and releases a small amount of explosives that drills a hole through the skull and destroys the brain of the human. And of course, his whole sales pitch is that for $1 million, you can get a whole plane load of these drones. And you can just imagine the havoc that would create in the world if this technology was true. Now, the fact of the matter is that none of this technology seems out of bounds, right? We have face recognition on our phones. We see drones that are flying around, helping farmers, but at the same time also doing photography in our weddings. So it's very commonplace, this technology. And in fact, some suggest that this kind of technology does exist and has been used in recent conflicts that are taking place in the world. At the same time, we are also seeing positive applications like Stanford University building AI that can diagnose pneumonia better, other US-based universities creating models that can detect heart disease. And people are asking, do we even need human doctors? So these are questions that we're all grappling with. We're also seeing humanoid robots like Pepper that is making entry into retail stores and replacing people who are working on the shop front. And we're seeing even pizza delivery being taken over by unmanned ground vehicles like this one here that was being trialed by Domino's a few years ago. And, recently when I was in San Francisco, this is the experience I had. This is a cab in San Francisco, a company called Waymo, where I was sitting in the co-pilot seat of this taxi without a driver, driving through the city of San Francisco. Now, all of this started back in 1945, soon after the World War II came to an end, when Alan Turing, a mathematician based in England, started to think about how, while these computers were very good at doing what we told them to do, we instructed them to do, and he was actually pivotal in breaking the German Enigma code that allowed them to actually eventually win the war. He started to think about how do we make these computers more human? How do we make them more intelligent? And in 1950, he published a paper that laid down the foundation. And he said that there are two ways in which we can model computers, right? One way was to sit down with domain experts, humans that actually were very good at a task, extract all that knowledge from them by interviewing them, codifying that knowledge, representing that in a computer, and giving the computer skills to deduce new knowledge, right? So you sit with a With a doctor, you extract information asking them how they do a diagnosis. You fill in all that knowledge into the computer, and then you give it logical reasoning skills that deduces new things, right? And that was what was called knowledge-based systems or expert systems. And people believed that that was the solution until, in the 1980s, they started to realize that it's very, very difficult to extract this knowledge from humans. Humans, firstly, are very expensive in that they don't have time to sit down and give you that knowledge. And secondly, there's a lot of what is called tacit knowledge, right? The word is tacit, which is knowledge that exists in the brain of the human, but it's difficult for them to describe. And so they basically gave up on that route and started to focus more on the second opportunity for doing, endowing computers with this knowledge, which is the machine learning route, right? Where you actually model the human brain, but that of a child, where a child typically learns through experiences, right? So you give computers experiences, and from those experiences, they're going to learn knowledge about the world and are going to then be able to, go from very specific experiences to generalized knowledge. And that is what is called induction, right? And so the world has, for the last while, been working on how can we build these machine learning models that can mimic essentially this child, right? So this child sitting in the garden is, maybe 1.5 years old, or maybe even 1 year old, with their eyes, which are their visual sensors. They're picking up what's happening in the world through their ears. They're picking up sounds through their nose, smell, taste through their tongue, and of course, with their hands and skin, they're experiencing things like temperature and other aspects also. So you have these natural sensors that are continuously collecting data from your environment, right? So let's take this child sitting in the garden, hears a sound going over their head, and through their eyes, they capture a video of an aeroplane, right? So we have this aeroplane here that has been captured. This child doesn't know what it's looking at, so it points at it and goes goo goo gaga because it doesn't even have the language to ask, what is that, right? And of course, the parent or the older sibling standing next to this child is going to say aeroplane, right? And so it's going to get a label, aeroplane, which I'm writing in text, but actually it's a sound, right? So it's more like a high frequency time series here, where it has picked up the signal that corresponds to aeroplane. And now it has this pair of data, right? An experience, which is the video that's been captured, and this sound that the child wants to replicate. So the next day, the child is in the garden, hears something going over their head, looks up, smiles, and says aeroplane in some kind of way, right? And of course, the elder teacher or the mentor that is with the child has a nervous breakdown. At that point, all their dreams of sending this child to IIT are destroyed, because as it happens, it's not a aeroplane, but it's actually a bird that is flying over their head, right? And so now the parent gives reinforcement to the child, a nice good old chaped, as we would say in Punjabi, or a thappad, and says, this is a bird instead. And so now the child has these two concepts, two videos, one of an aeroplane, one of a bird. They also have the sound aeroplane and bird that is paired with that experience. And from that, they seem to be able to learn a function that maps a video onto either aeroplane or bird, right? And typically this is done through extraction of features. So it might extract the features that this object here flaps wings and this one does not. The aeroplane does not. Maybe it has a beak, and this one does not, right? And so no flapping wings. And from these features, then it learns to discriminate between these two. And we call this a discriminatory function, right? Or a discriminative model. It learns to, given some input, discriminate between multiple concepts. Now, I have talked about physical objects here, but typically it could be anything. It could be what is a table, what is machine learning, what is cybersecurity, right? All of these are examples of concepts that the child is learning through exposure to different content, different inputs, right? And amazingly, you know, the idea of induction can be modeled very much like a neuron, right? And so obviously, when we are trying to make a computer intelligent, we are going to start to think about what brings intelligence into the human body, and we typically attribute that to the brain. The brain consists of cells that are called neurons. They have these things called dendrites that are inputs to the cell. And every so often, given the inputs that go into the cell, there is an electric current that comes out of what is called the axon, which is the output of this computational cell within our brain, right? And so we can think of it as an input where we have various numbers going into the function. We obviously have to convert our video into this set of numbers, and this is something that we'll talk about. But then we also have weights associated with the edges that connect the input to the output, and these weights are multiplied by the inputs. So we end up with some value Z, and then we pass it through something which is referred to commonly as an activation function. And that activation function, the simplest activation function you could think of is that if the sum is greater than some threshold, then pass out 1. Otherwise, if it's less than that threshold or equal to that threshold, then the output will be 0. Right? So that's one form of activation function we can use. Of course, there are multiple different functions that can be used here to do this output. Now, when we model our computation in this simplistic manner, what ends up happening is if we are trying to discriminate a cat from a dog, what we can create is a linear decision boundary here, right? So we are assuming that we have feature 1 and feature 2 that have been extracted from images or videos of dogs and cats. And it so happens that by drawing a line between these two, we can actually predict for the next image that comes along, which might sit here, that it is actually an image of a dog. And if there is any point here on this side of the line, we are going to classify it as a cat, right? And so this was the basic computational model that was created. It was called a perceptron. And this perceptron, everybody was very excited about it. They believed that was the solution until they realized that actually all this is capable of doing is defining this linear decision boundary. And so a lot of the problems in the world do not have linear decision boundaries. And so we will have to go beyond a single perceptron, right? And this discovery that perceptrons are not the answer to all our problems actually led to what is called the AI winter, right? Where people gave up on AI and said, no, this doesn't work. It's never going to work. They stopped funding it. But then what these researchers found was that it isn't just about one perceptron. Our intelligence doesn't come from one cell. It actually comes from the interconnectedness of cells. And so a child has a lot of neurons, but there is no interconnectivity between them. And these interconnectivities form through experiences in early years. And that's why even when we look at, developmental psychology and so on, we actually have found that exposures that children get in the formative years, the first 5 years of their lives, are really going to define how intelligent they are, right? And this is the biggest problem with the fact that in developing countries, children don't get the exposures that they do in developed countries. And therefore, there is a gap in capabilities of these children in developing countries versus developed countries. And research then found that actually what's happening here is the inputs go through neurons, like the eyes have neurons themselves. So the inputs are coming in from there. And then you have multiple processings that happen from one neuron to the next, where inputs to one neuron are translated to outputs from that neuron, and that output from this neuron becomes an input to another neuron. And so you have this hierarchical structure, and we call these hidden layers. Right? And so there's processing that happens from the inputs in multiple stages. And then finally, the output layer is actually producing a linear decision boundary still, but in a space that is different from the original input space. The input space has been transformed. And so we can say that these internal hidden layers are doing feature engineering and finding a representation of this data where we can now draw a decision boundary that is linear. But in the original input space, this could be a very complex decision boundary that is very curvaceous and finds all sorts of interesting decision boundaries. And this is what is referred to as a neural network and forms the basis for all of the success we have seen in artificial intelligence over the last 10 years. Now, of course, this didn't happen in one big bang. A lot of people think that AI happened in 2022, November, when OpenAI came out with ChatGPT. But there have been successes along the way, right? So in 1997, Gary Kasparov was beaten by IBM's Deep Blue. A lot of the initial research there was also done at Carnegie Mellon University. But essentially, Deep Blue was a kind of a hybrid. It was given a lot of knowledge about chess, and it was able to, because it was a very powerful computational machine, it was able to look ahead at what is the outcome that would happen if the computer made a particular move. What would Gary Kasparov do? What would it do in return? And because it can look deeper into the future, it was actually able to beat Gary Kasparov in 1997. It took 19 years from that day to actually beat the world champion in Go. But the world champion in Go said, when it lost to AI, that AI was making godlike moves. And he couldn't understand why the move that AI was making made sense, because a human would never make that move, right? He couldn't even understand why AI was making that move. In previous years, when he had played AI, he could understand the moves. But the biggest difference between AlphaGo and the Deep Blue that beat Gary Kasparov in chess was that AlphaGo learned how to play Go by playing with itself, right? So it was able to learn through simulations and didn't have to be taught how to play Go itself, right? And this is the big change that has taken place over these 19 years. And so not surprisingly, people even like Geoffrey Hinton, who is in many ways the grand old father of AI, who has developed a lot of the technology that has led to AI being as successful as it is today, had made a claim in 2016 that we should stop training radiologists. This was based on computer vision. It wasn't based on anything to do with natural language, nothing to do with the large language models that we are looking at. And he said, if you're training like a radiologist, you're like this cartoon character that is being chased by this other one that is so focused on what they're training in or running away from, that they don't realize that they're going to fall to their death. They're not going to have jobs. Now, the truth of the matter is it's almost been 10 years since this claim, and radiologists are still required. Having said that, we can see that AI is having an impact across many, many fields. In 2024, the Nobel Prize in physics was actually won by Geoffrey Hinton and John Hopfield. And at the same time, Geoffrey Hinton is becoming one of the biggest critics of how AI is being developed. He left Google as well that year, saying that the big tech companies are not doing enough to control AI. And so that fear that AI is going to destroy the human race and is going to cause a lot of problems still exists. Now, obviously, computer vision made great strides from 2010 to 2020 or so, and continues to make strides even today. But in 2018, there was a new architecture for neural networks created, which was called the transformer. And this transformer architecture is what has fueled the neural network revolution in natural language processing. And so in June of 2018, the first GPT model was created. It was created on a relatively small amount of data. The model itself was also quite small. When we talk about a model, we are really saying the number of parameters. And what are we talking about when we're talking about parameters? It's the number of weights, right? So you can see we have a weight matrix here, a weight matrix here, and a weight matrix here. So the total sum of the number of weights that we are learning within the neural network is what we define as the size of the model. And since that June 2018, when GPT-1 was created, there's been a huge amount of money, computational power spent on developing this further. And it was in November of 2022 when GPT 3.5 was released and ChatGPT sat on top of that, that the world got to know about this space of what is called generative AI. Now, in the world of machine learning, we had been talking about discriminative models, and you saw one of those and how it works. Discriminative models. And we also actually talked about generative models. Right? And what we discriminated between these two types of models, how we talked about the distinction between these, was the fact that a discriminative model learns the probability of y given x. What is x here? This is the features extracted from the video. And y here is the label given, right? So whether it's an aeroplane or a bird. And so we are learning a probability distribution of what is the label given x. So we are able to generate a label, but that label is really not generated. It is from a set of labels, right? So it's aeroplane and bird. So we are selecting one of these labels rather than generating them. At the same time, we are not generating the video. The video is an input. A generative model instead learns the probability of x and y. So it is able to generate data similar to the data that was used to learn this probability, right? So all of this training data that we are collecting, the experiences that we are giving a machine learning model, that is considered to be a sample of all the data that could be produced. And from that, what we do is we estimate the parameters of the model. And that model is really representing the joint probability of the inputs and outputs. And as a result, we are now able to generate data from this that looks statistically like the training data that has been input. So that's where the term generative comes from. Now, in those days, typically we worked with what was called structured data. Data that looked like a table. And the kind of applications we were trying to solve was, should we give a loan to somebody or not give a loan, given various input parameters that we have or input data we have from the application form, right? And so every row was one experience that the bank was having in deciding whether we should give a loan, yes or no. So this was the structured data where it had a predefined set of input variables and a predefined output that we were trying to predict. Now, in the space of natural language processing, what we are doing is we are dealing with text. Text is not structured. So the input is text, the output is also text. And that text that is output is not from a selection of possible labels either, right? And that's why when we talk about generative AI, we are basically saying we have unstructured data as input, and we produce unstructured data as well, right? So the output is also unstructured. It could be text, it could be images like this one that's been created by AI given the right prompt. It could be music, it could be a poem, it could be a song, whatever. So while the world was very excited about our ability now to speak to computers as a result with languages that we have used typically to speak to each other, which is things like Hindi or English or Punjabi or Kannada and various other languages, there was a revolution happening in science too. And that revolution that was happening in science was pretty much hidden from most of us, right? But essentially, the same company that created AlphaGo created a model called AlphaFold. And this was aimed at predicting the three-dimensional folding structure of proteins. We find proteins within our human cells body. Inside the cell, a protein is essentially a sequence of amino acids. But just knowing the sequence of amino acids doesn't tell us anything about the function of the protein. And it is the function of the protein that protects us from diseases and various other issues, right? And so whenever we get attacked by a virus like the coronavirus, it is because of our protein structures and the protein structures in the virus actually engaging with each other. And so getting to know these three-dimensional folding structures of proteins actually can help us fight disease. And AlphaFold, actually, the outputs of AlphaFold actually contributed even to the creation of the vaccines that we had in COVID and are going to now fuel what is called personalized medicine. Right? So this was a huge leap in science that took place. And where humans had only a 40% accuracy at predicting the three-dimensional folding structure, given very expensive tool sets that had been created by scientists, by 2020, AlphaFold had actually hit 90% accuracy. And now it's even higher than that, right? And so these were big breakthroughs, and this led to the Nobel Prize in Chemistry being given to AI scientists, right? Which is kind of incredible when you think about it. In 2024, the Nobel Prize in Physics and Chemistry was won by AI scientists. Now, how does that impact me, right? It impacts me because I used to be the dude that could talk to computers. I used to write these Python programs, and people who couldn't write Python programs couldn't get the cool jobs that I could. I was a mathematician by training, so I had mathematics and the ability to talk to computers, and that is the mix that is required to be able to work in artificial intelligence and machine learning, right? Because there's a lot of mathematics. You've already seen probabilities being the bedrock of all models that we're creating. So neural networks also are learning probabilities, right? Every modeling technique, whether it is an ensemble modeling technique like random forest, whether it is a decision tree, whether it's logistic regression, we're learning probabilities, right? Now, my coolness disappeared recently because now we have software like this one, which is called Cursor, where you can now talk to it in English and it will produce Python code for you. And as a result, Airbnb recently said that they were going to do, a migration of their code, which they had predicted would take 18 person months to do. They were able to do it in 6 weeks using AI. And so essentially what's happening is that every field we look at is changing. And why is it changing? Because of the efficiencies that AI are bringing. Now, many people ask me, well, should we not learn coding? Absolutely incorrect. You should learn coding because AI can write these standalone programs right now, but you are the glue that is going to pull this together into creating larger, complex solutions for the world. All that has changed is your role. It's not good enough to know how to write syntax. You have to become a problem solver. And these are what are called durable skills. Skills that are going to be important in tomorrow's world where we are using AI as a collaborator now, not as a servant, but as a collaborator, where AI has more knowledge in many domains than I do. We can collaborate. I have to have the ability to ask questions. And this is why we say critical thinking, communication. Because if I don't know how to talk to humans, I'm not going to know how to talk to AI and ask for what I need. And creativity. These are the key durable skills that you need to develop. And typically in engineering degree programs, we don't give you these, right? So it is up to you now to decide what to do. Now, we're obviously getting into a very uncertain world. And rather than fearing that, what we need to do is we've got to deal with it. And the way that you need to deal with that is to create skills, right? Beyond being knowledgeable. You need to reflect on what you're learning. You have to get deeper. You have to be a good communicator. You've got to be a risk taker. You've got to be principled. You've got to make sure that what you're building is ethically fair, right? And so on. An inquirer is really, really important. Learn how to ask questions. Ask questions of humans, your teachers, your professors. Ask questions of AI to make sure that there is nothing you don't understand. Because that deep understanding is what you're going to require. What you're going to require is a passion for disruption and invention. It saddens me to see that all of these inventions that are coming from the US. Indians are in the US contributing to those innovations. But when it comes to innovating in India, we are still lagging behind the rest of the world, whether it is China, whether it is the US, whether it's Europe. And the reason why we are doing that is that our education system isn't engaging us into being passionate about what we are learning. We are learning to pay our bills, and that's not good enough, right? And so what we need to do, what you need to promise me today is that you're going to go away and say, I'm going to make friends with emerging technology. I don't care about the job. I'm going to create a business instead. I'm going to create jobs instead. And what we need for that is for you to develop the ability to take ownership of your own learning, not waiting for somebody to come and lecture you like I'm doing today or your professors do, but to actually say, I am going to learn continuously, because you'll have to do that, right? There's a lot of talk about how, people should work 72 hours in a week. Whether we believe that or not, we should be learning 72 hours a week for sure, right? And we must make sure that that is the case. And, if you haven't watched this movie, I loved this movie. It's called The Martian. It's about how this, NASA astronaut that gets left on Mars uses his skills, the theory he's learned about botany, to create water on Mars, to be able to cultivate potatoes on Mars and actually survive till his mates come back to get him. Now, what I want to do is to transition a little bit more into the technical side of things. up until recently, and in fact, there are still applications of narrow AI. What we have been talking about, even in terms of the loan applications and so on, we typically think of machine learning as being you collect data for a specific problem. Here, the problem is we have inputs from a form of people applying for medical insurance. And here we are actually trying to predict what should be the premium they pay based on the risk of hospitalization. From that data, we build a model. We then deploy that model into using a RESTful API like fast API and so on. We deploy that as a model which then integrates in with software, and people in the business can work with that model. We monitor how well that model is doing, and we create a pipeline that continues to learn from mistakes it has made in the past. And this was it, right? This model that was built could only predict what is the premium for health insurance. And therefore, it was called narrow AI. What we have more recently developed is a much broader sense of AI, a model that can talk to us about pretty much anything. And why we have achieved that is we have achieved that by being able to create this natural language ability within computers, right? And when we think of natural language, like English was created for humans to communicate with each other. And the whole idea was that if you have a concept in your mind here and you want to transfer that understanding of that concept to another human, we can't just beam down our neural representation of the concept, which is a set of weights connecting neurons, to the other human, right? That's not possible, at least as of now. So what we need to do is we need to take our neural representation and we do what is called decoding to generate a set of words, right? So we do a sequence of words is generated through this decoding process. And these words are then transferred to this human. And this human then takes these words, the recipient, and it encodes these words into the neural representation. Now, this language of English or any other language, in fact, is very ambiguous. And this decoding process, might make complete sense to the sender of this information, but the recipient, because they don't have maybe the domain knowledge required to interpret these words, is unable to create the perfect representation. So here the concept was obviously an elephant, and here it's learned the concept of a fan instead, right? And so this ambiguity that existed, the need for certain common sense knowledge within the human was a huge overhead in natural language processing. And so when we looked at trying to model this within a computer, the big problem that came up was the fact that computers did not have this common sense knowledge. And so if we told the computer that here are three words, cat, mouse, and tiger, it would treat all three words. These are just tokens that we have created to represent what is in our mind, right? We as humans have said that a rat looks like this, right? I'm not very good at drawing, but anyway, right? So a rat looks like this, a mouse looks similar, and a tiger, of course, is very different, right? And so we've given these labels. Now, the reason why when somebody says tiger, we can imagine a ferocious animal is because we have this common sense knowledge. But computers didn't have that common sense knowledge. And so there was no way for a computer to know whether a rat and a mouse are more similar to each other than a mouse and a tiger. And this was the big problem that we were facing in being able to do natural language processing. And this changed when we came up with the ability to map words onto numbers. And we refer to those as word embeddings, right? And essentially, some researchers in Google, and then of course that was followed up with some researchers from Stanford as well, created the ability to say a rat can be mapped onto coordinates like these, and a mouse can be mapped onto coordinates like these. And a tiger then gets mapped further away, maybe 0.6 and 0.31. Right? And what that means is we can now map these into a two-dimensional space where we can see that animals tend to cluster together, food tends to cluster together, drinks get clustered together, and countries get clustered together, and so on and so forth. Now, why is this a big deal to be able to do this? And how did they do this, right? How they did this is very interesting. So what they did was they said that we have very large amounts of text on the internet. And if we look at any word, which is referred to as a center word, the words that appear on either the left or the right of this is going to really give us an insight into what this word means. So a rat and a mouse, because they're typically found within domestic settings, they might talk about kitchen and maybe sewers and so on, whereas a tiger will never be found in a kitchen or a sewer, right? And so the words that appear around these, if we look at the distribution of those words across a very large number of occurrences of a particular word like stairs, looking at that distribution of words and comparing that distribution with the distribution for another center word, if they're similar, then we can assume that the two words have a similar meaning as well. And so this idea of a word is known by the company it keeps, which is what at least my parents would always say to me, that if you hang out with the naughty children in the colony that I was growing up in, then I will also be considered to be naughty. And if I am with the intelligent and the geeky children, then I will also be considered to be geeky or intelligent, right? And so the same idea was used here, and they mapped all of the words as a result onto these numbers using this mechanism. Now, why is that cool? It is cool because essentially, if I am to produce a set of words, I will have to say the word is the. Now, what is the next word? If I want to know what the next word is, it's obviously going to be based on what has been said previously. And the more information I have in terms of what has been said previously, so if I go, the rain in Spain stays mainly. I have lots of text here and I want to know what's the next word. I have a better chance of knowing what that is, because what I'm saying is it's the probability of any word from my vocabulary given the sequence of words that has gone by. Now, to learn this probability, I would need to learn the probability distribution of any sequence of 1, 2, 3, 4, 5, 6 words. Right? Any sequence of 6 words, given those, what is the probability of every word in my vocabulary? Now, if my vocabulary is 1 million words, then how many combination of 6 words can I have? 1 million to the power of 6. And for each one of these combinations, I need to know what is the probability of every one of those million words. So the total number of probabilities I'll have to learn is very, very large. Right? 1 million is already 10 to the power of 6. To the power of 7 is what I'm looking at. That's too many probabilities to learn. I don't have the ability to learn that. Right? Now, what happens when we now map every word onto a d-dimensional vector? where D is now, I was showing it as 2 here, where I was saying every word gets mapped onto two-dimensional space. The fact is that 2 dimensions is not enough. So typically we map it to maybe 100 or a 300 or even 1024 dimensions, right? And even larger embedding models exist. Now, by doing that, we are now able to say that every word gets mapped onto this d-dimensional vector. And so you have VD parameters to learn. And the probability of every word here, this is a neural network that I have. This is the input word. And this is the output word. And I'm mapping every word into a d-dimensional. So this weight matrix here is going to be V times D. And then I'm going to multiply this again with another weight matrix, which is D by V, which gives me the probabilities for every word. And so how many parameters do I have? 2 times V times D, which is a lot less than what I needed here. Of course, you can say that I'm only inputting one word here. So this is really the probability of a word given the last word spoken, right? But even that would require V square parameters if we did not have this d-dimensional mapping of the word. So then what researchers did was they created these recurrent neural networks. And what did the recurrent neural networks do? They actually said, you feed me one word at a time, and I will output a representation of the word, including all the words prior to it that have been fed to my neural network. So here, I'm feeding in the word the, but I am getting a representation of the whole sequence of words as another input into my neural network. And so we are doing 2 things. We are representing memory of what words have already gone past. So we are creating an embedding of a sequence of words now rather than a single word. And that becomes an input into this neural network. And so to map the input word, which is d-dimensional, and the mapping of the word, which is concatenated. So now we have a 2D vector that is going into the neural network, and that is getting mapped onto all of the words of the vocabulary, which is D times V, right? And so for any sequence of words, we are now able to map it, not where the number of parameters is increasing, by a very large number. It's basically a linear growth rather than an exponential growth in parameters. And so even though we now have billion parameter models and trillion parameter models, it's because we are able to do many layers of neural networks and learn much more complex probability distributions than we could previously. Out here, we were unable to do it because we didn't have these embedding models. And as a result, now, what the problem with recurrent neural networks was that while in theory, it could create this representation of memory for infinite sequences, in reality, there was a problem. And the problem came more from the backpropagation algorithm that was used to learn these weights. Because the backpropagation algorithm had to pass back this long sequence of inputs, and it couldn't basically do the learning that it had. And so in 2017, there was a paper that was published by Google called Attention is All You Need. And they came up with this transformer architecture, where you still had an encoder that encodes all the input, your prompt, and then it feeds the embedding of the input into this, what is called the decoder, that then produces probabilities of words that could be generated as a response to the inputs that came into the encoder. And given those probabilities, using something called beam search, we are able to produce a sequence of words. And that sequence of words is different every time, even if the input is the same. So the generative piece actually comes from the ability to generate the probability distributions, but then also the ability to search through a sequence of probability distributions for words that allows us to produce different text each time. Now, these large language models are all using transformer architectures. They have consumed all the text on the internet and are fueling all of these chatbots like Anthropic, like OpenAI, like Gemma, and Llama, which is the Facebook equivalent, or DeepSeek. Now, the problem with these is that the transformer architecture is trained on some cutoff date, right? So 6th of June, for example, 2025 may be the date that the transformer architecture was trained on all the text that existed within the world. Now, if we ask a question, for example, we say, what are the flights I have to fly to Goa next week? It won't have the answer because flights are very dynamic. And so what has changed now is that these systems are not just large language models, they're actually AI systems that incorporate a lot of tools. One of the tools may be a Google search API. Another one may be access through an API to Expedia, for example, to get flight information, and so on, right? And so now when a user asks a question, it figures out whether the answer sits with the transformer or whether it should hit one of these APIs and retrieve information and pass that back to this user. But of course, when it came to companies and companies utilizing this technology, what they realized was that there were lots of documents that they had that were not on the internet, and they did not want to put on the internet because they were not public information. It is their crown jewels, right? Information that is private to them. And so what these large language models were extended with were these retrieval augmented generation capabilities, where within the organization, a business, for example, could expose their documents to a large language model using this mechanism called RAG, or retrieval augmented generation. And what you do here is you cut up your documents and you vectorize them, just like we were talking about the word embeddings and the sentence embeddings. You create embeddings for chunks of content. And whenever a question is asked here, a prompt comes in from a user, you check for whether there's relevant chunks in your own corpus, you add that into the context of the prompt that is passed to these large language models, and these large language models then produce an answer and send that to the user that is based on your own text. Now, while this sounds simple, there is a lot of complexity to creating RAG-based systems that are useful in industry, right? But this is where the industry is. And finally,
Sir.
Yes.
Good morning, sir.
Good morning.
Sorry to interrupt you.
Yes.
Sir, we have already 900 plus member
Uh-huh.
watching on YouTube. Okay,
Okay,
and they are really appreciating this session, and they are ready to be friend with emerging technology.
great, excellent. That's fantastic. That's
Yes, sir.
fantastic. So I'll just wrap up in a couple of minutes, and then I'm happy to take some questions if
Uh,
there are any. Right?
sir, there is no time limit. You can uh, show full PPT here. People are
Okay.
really liking your session.
Okay, great, great. Well, I'll wrap up in any case. I think there comes that point where we'll have to talk again sometime. But anyway, so I wanted to wrap up by really talking about the fact that we've got large language models. What's the future? And as a lot of you would have heard, okay, so one important thing, right? So large language models make mistakes. We call them hallucinations, but they're really mistakes, right? From a marketing perspective, we talk about hallucination in English, where a human can hallucinate when they believe that um, something is reality, but it's not. Their imaginary world and reality starts to overlap with each other, right? And so, from a marketing perspective, if we've created artificial intelligence, then to say that it makes mistakes is not useful when you're trying to sell, right, your technology. And so, we talk about AI hallucinating instead, but the truth is it makes mistakes. So one thing that I want you all to remember as you use large language models is don't trust them. You must question it. The critical thinking that I was saying is an important skill, durable skill. You must use it in your own learning. When you read something, you don't quite understand it. Typically, in a lecture like this, you feel embarrassed about asking a question. With large language models, when it gives you an answer, ask a question. You don't understand something in the answer, ask a question. If you don't agree, say you don't agree and give it your reasoning for not agreeing. It'll then revise what it's saying to you and give you the right answer. Now, this young lawyer in America a few years ago, 2023, was given a job to do, which was for a particular case to create a brief, right? And to create a brief in law, you actually go and look at what were previous cases similar to this one, what was the outcome, and you actually use those as citations within your brief. Now, this young lawyer became lazy. He went and used ChatGPT and created a brief and gave it to his senior lawyer. The senior lawyer himself assumed that the junior lawyer actually did good research. So he didn't check it very carefully. They gave it to the court, and the judge found that all the citations in there were hallucinations. They were incorrect. Were cases that had never happened. And so obviously this poor kid lost his job. The senior lawyer was very embarrassed, and it obviously wasn't a great outcome for them. Now, what is going to happen is we are going to now create these assistants in every job, whether you are a radiologist, whether you are a lawyer, whether you are a software programmer. These assistants are what are referred to as agents or intelligent agents. And an intelligent agent is kind of like a software robot, right? We have large language models. Large language models are great for understanding English. So when we can communicate in English, which is great. But then what do we do after understanding what the ask is? And is English enough? Clearly not, right? We as children or human beings are using all our sensors, our eyes, our nose, our taste buds, our ears, our skin. So the intelligent agent, to truly mimic a human, needs to perceive the world through various sensors. And of course, a lot of these sensors exist, right? We have cameras, so we have the eyes. We have the ability to listen through microphones. We have the ability to now speak through speakers, right? Perception of temperature, we have temperature sensors, we have moisture sensors, we have all sorts of things that give us some information around tactileness of our experience, right? What it feels like. Given all these inputs, next, what do we need to do? We need to process those, and we have to access our memory. What is our memory? We've already seen a corporate memory is retrieval augmented generation, knowledge that we have created by interacting with the world. We want to reflect and learn, process long-term memory. We need to have long-term memory, look back and pull out from long-term memory what is going to be useful in the situation we find ourselves in, right? So perceive the world is the situation we find ourselves. We then have to use our knowledge to act. When we decide to act, we may need to use tools, firstly, to gather more information, to be able to decide what to act, or we might, through tools, take action. If it's a complex problem, we will have to reason about and create a plan of how we actually act upon things. And finally, we need to collaborate, right? So multiple intelligent agents may have to collaborate with each other. So an agent has to have all of these different aspects to it. And when we have agents that can now collaborate, we call them multi-agentic systems, where we create workflows, right? So say you're a busy executive here. In your calendar, you're putting in, I have all these meetings to do. The meetings may be all over the world. Now, the orchestrator or the router agent may identify by reading your calendar that these are all the meetings you need to do. It will pass on information about these meetings to an agent that will book flights, another agent that books hotels, another agent that books a car, and another agent that may choose restaurants that you could take your clients on, and so on. And all of these agents are going to collaborate and come back with a plan for you, right? And say, this is what you need to do. Now, in that multi-agentic systems, there will also be evaluator agents that are looking at the plan and evaluating whether there's some hallucination in there, identifying whether there are some issues there. And then the final plan will be returned to you as this executive, where in an automated way, your life is becoming easier. Now, the question comes back to, if your life is becoming so easy that you're not needed, do you lose your job? My suggestion is that if you know how to use AI right, your AI can become very useful helpers, right? And you are freeing up your time to do the creative thinking, problem solving that AI cannot do today. But it's a race. AI has greater bandwidth to consume more information than we have. AI has more computational power to process information than we have. What we, though, have is the creativity and the ability to think critically, which is much better than what AI has today. And so we have to be intelligent about how we build skills as we work towards joining the workforce. And so I shall stop here and take questions. Thank you very much for your time. Thank you for being great listeners. And I apologize for going a little over an hour here, even though I've been told that there is no time limit. But I hope this has been useful for all of you. And like I said, I'm happy to take questions, and happy also to provide any guidance that anybody may want.
Thank you so much, sir, for your grateful time.
You're welcome.
And really, all the participants are really interested to become the friend of emerging technology. I am really shocked.
Great. Well, connect with me on LinkedIn. we have a program that we run, and I know some of your colleagues have actually taken advantage of that program. It's a 6-month program that we run through Sabudh Foundation. You go to sabudh.org, you can apply for it. We are actually now taking applications for the next batch. And actually the last date is today. So get on with it if you want to apply now. And we look forward to interacting with you further, whether or not you join Sabudh.
Sir, many of them already registered for data science field.
Fantastic. Great. Okay.
Sir, now moving forward to question and answer session.
Yes.
Sanskriti, to you.
Yes, sir. First of all, thank you so much for this enriching session. I'm pretty sure, all the third year students present here, we have machine learning as our subject this semester. And I'm pretty sure I can say that from behalf of all my batchmates, that whatever we learned in this 1 hour was more than what we learned in our classes in the semester. I am pretty sure about it. And yeah, the session was very fruitful, I think. And I hope that many students that were watching through the YouTube live are interested in this machine learning. They have just started their career, their engineering. Like, we targeted the first year students, and they are very interested. I'm just reading the questions they have. So let us start with the Q&A session right now. For most of them want to know how they should start with machine learning when they are not from a CS or IT background, when they are from ECE, electrical. So what should they do to start with machine learning?
So, to me, the best thing is read a lot, right? There are a lot of blogs there. There are a lot of YouTube content that's there. Engage with the content. We've seen a lot of debate around, life-work balance and all of these kinds of conversations. There are a lot of people saying, no, we shouldn't be working very hard. I disagree with that, right? Yes, as an employee of a company, if a company is asking you to work beyond 40 hours, I think that's unfair. But you have to invest in yourself. You have to consume content, right? There is great content that's out there. If you want a structured mechanism, then by all means, connect with us in Sabudh. We'll be able to help you with that. While students join our program, and it's very competitive, right? 1 in 10 students get into the program. But we are happy to make our content available for you to consume and for you to use our mentors to get answers where you get stuck. You have to learn Python programming. Yes, there are low-code, no-code platforms, but they are limited in what they can do. You should engage with cursor.ai and tools like this doing vibe coding, but understanding is very, very important. The world says that, you don't need to learn Python now, you can do vibe coding. It's nonsense. We still need to understand. Otherwise, we will not know when the Python code that's being generated is incorrect. Because if we can't describe correctly what we want, AI will generate stuff that is not producing what we want. And I have, in my own experience, seen I have to, with very simple problems also, have follow-up questions being asked, right? So understanding Python is important. Using vibe coding technologies like Claude Code, like cursor.ai are very, very important. And there are others, of course. Then, you're all engineers. You're capable mathematically. Again, it's not fashionable to say get into the core understanding of the technology these days, because everybody says all you need to know is you need to know certain Python libraries that allow you to leverage LLMs. But I would say LLMs is one tool in your toolbox as you go forward, right? For ECE people, learn about embedded systems. Learn about how you reduce the size of these models to put them on the edge. Edge computing is very, very important, and edge AI is going to be very important. We have an AIoT program also at Sabudh, not just a data science machine learning program. Engage with that. Life is tough. Don't assume this to be easy, right? Get in there. Don't lose heart. Don't give up. That's my only thing. It's very easy when you're getting something for free. to give up and say, "Acha, mere to paise nahi lage, I can just leave it and forget it." You are doing harm to yourself. You have to engage. Your learning is what is going to make you successful. You not learning from me doesn't make a difference to me, right? So the important thing is do it for yourself, do it for your country. Yeah, so start with Python, start with mathematics, engage with content. I am happy to make that content freely available to even those people who don't get into the program. But it is for you to make a resolution. I'm going to stick to it. It really is going to be very tough for those people who don't learn to learn independently. I have to learn every day today myself because there's new things happening, right? So if you are going to give up at age 18 and 19 and say, no, I will only learn if somebody teaches me in a way that I can learn, that's not good enough. You have to become your own agent of learning.
Thank you so much, sir. And while we are talking about Sabodh, I would also like to thank you for making the program free of cost in a day and era when everything basic learning is a basic right. I feel like, and learning is monetized in this era, and in this monetization era, you have made the data science, machine learning, and AIoT affordable for students like us who can't, access the monetary education. So thank you so much for that. And furthermore, let's move ahead with the questions. The next question I would like to ask is, there is someone in the chat who wants to know how did you get into machine learning when it was not even, mainstream? Like 30 years ago, how did you get into it? What interested you? And what are the challenges you faced in your journey? Please share about it.
So I got into machine learning with God's grace, right? That's the only answer I can give. We call it Guru Di Kirpa in Punjabi, right? I went to England. I was lucky enough to get admission to do my master's after I did my maths degree. I finished my maths degree from Delhi University in 1990. And I got an opportunity to go to Ireland, where I did my master's in engineering computation. With God's grace, I did very well there. So I got a research position. And in that research position, it was actually, I was being funded and I had the ability to do a part-time PhD. That PhD was actually in an optimization problem of figuring out how to put reinforcement in concrete slabs so that it can take the weight. It was in civil engineering, right? And after a year, I got bored of it and I said, I'm going to go crazy if I do this. So I gave up. I failed, right? And it's important for us all to recognize that failure is a good thing sometimes, right? We should not be scared. When we fail, it's because we have gone out and tried to do something we may not be capable of, right? So get out of your comfort zones and try things. When you fail, you don't give up. You actually learn from that experience and say, let me get a research position. I did in something that is of more interest to me, right? And it was a bold decision to make. I could have continued. I would have got a PhD in civil engineering and I could have made a life for myself. Living in a foreign country where your visa is dependent on, having some kind of a job, I still gave up that job. Again, with God's grace, I got a job in a computer science department this time, where they put me on a research project. And that research project was to do with large amounts of data and trying to report on large amounts of data. Now, that project finished early. And my professor said, hey, there's this thing called data mining that is becoming very popular. Data mining was the word given to machine learning as it came out of the labs and started getting used in industry. And so back in 1993, I was lucky enough to get pushed by my professor into machine learning. And at that time, we didn't even have a conference on data mining. It was a workshop at AAAI, which was the big premier AI conference. And I got involved at that point, and soon we got the KDD conference, which is now the largest conference for this space. And I was just lucky to get that exposure from the early days. And so it was not something I intentionally did. I was interested in kind of how, I'd been hearing about knowledge-based systems and so on, but it was really God's grace. And I just wanted, the reason why we started Sabudh was we want to bring that same God's grace to everyone without anybody having to travel abroad to do it, right? And we recognize that there isn't as much available here in India to get access to good training in this space. And that's what we are trying to achieve. Of course, there is always a double-edged sword to give something for free. If you give something for free, people don't value it, or people think they can drop off and it doesn't matter. But like I said, our objective is to make it available to you. We can bring the oasis to the camel, but we can't make the camel drink the water, right? So in the end of the day, you have to be the camel that drinks the water. And this is my story. Thank you.
It was very inspiring, sir. And to think that we are in conversation with a co-founder of a very, important organization such as Sabudh. So moving on to the next question. Someone in the chat wants to know, what do you think about the integration of AI and quantum technology?
So, obviously, partly why AI has exploded recently is that we have a perfect storm created by data being available digitally. A lot of data, the internet caused that. And COVID increased that even more, right? We also have GPUs, which is the hardware, to be able to do the level of computation that is required to train these very large models. Even small neural networks earlier, 20, 30 years ago, used to take weeks to train, right? And the data volumes were small. So we have the data, we have the algorithms, and we have the hardware to produce the AI that we have. Now, quantum computing is going to take the hardware, the computational capabilities to the next level, which is going to mean that we are going to be able to create much larger models that are capable of doing so much more, right? So I think it's definitely going to be a contributing factor to what is going to happen next with an AI.
Thank you so much, sir. And our next question is, what do you think is the most misunderstood concept when it comes to AI and ML algorithms?
Well, I think one of the big things is that a lot of people think of AI as magic, right? And I think that is the biggest problem. In the end of the day, AI is a probability function. It is being able to predict beyond what has been given to it, right? And so in many ways, there is no magic to it. It is actually being able to learn a probability function on data that is incomplete, right? And so thinking of it as being something mystical is not right. We should be able to understand how that learning process takes place. I think we have over-engineered some of our models. We have gone to have these trillions of models, trillions of parameters, very large embeddings. These are all now going to start to reduce. And we are going to get efficiencies in the AI that we're going to see in the future, right? But really, I think the important thing for people to realize is that if we manage the creation of this AI well, it can be hugely beneficial to every domain. We shouldn't see it as a risk. We should see it as a co-worker, as a friend that can help us be more efficient. We shouldn't give up, because to give up and to say AI is going to now take all my jobs, I don't know what I'm going to do, I'm going to freeze up, is the wrong thing to do. AI will not take your job. A person who knows how to leverage will take your job from you. So that is, I think, the important thing for us to remember.
Thank you, sir. I actually had a question of my own. If it's okay if I ask that.
Sure.
Yeah, so when we talk about AI right now, I mean, I hope you've heard about the recent Nano Banana
Yes.
model of
Yes.
Gemini. It can, the photos it generates is almost नहीं, बहुत मतलब पूरा ही identical है. It's very very real. So do
Yes.
you think that kind of model would be would be hazardous to us common people, like making that available to the folks in India, especially where we have almost our identity is basically Aadhaar card and PAN cards. It can be generated very easily using the models that we are having right now. Do you think this surge in hazardous use of AI can, decrease and make it less stable for us to have a job in AI in the future? Like, I'm asking if it will reduce.
Well, so there are hazards of AI, right? For sure. I mean, deep fakes is a real problem, and this would feed the ability to very easily create fakes as well. In the end of the day, when we got nuclear technology, also, it had the ability to kill thousands, hundreds of thousands of people. At the same time, it had the ability to solve our problems from an electricity generation perspective as well. So I think the AI technology is there now. Whether we give it to everybody or we hold it back, in the end of the day, these large organizations like Google and OpenAI are not pillars of ethics also. Right. So for us to say that, now we should only keep this technology in their hands, who are they? I mean, they are corporations that their focus is about making more profit for their shareholders. And that's what they have been developed for. They're not governments. Even governments can be rogue, right? In the end of the day, this is a big problem. And I don't think there's a simple solution for this. Countries are trying to regulate the use of AI. They're trying to make sure that, there's some kind of watermarking on images to be able to say this is AI generated and so on. But this is a hugely difficult problem. And, I don't think there is a well understood solution to it. But I am not sure whether, keeping it away from some people and only some people having access is the answer, because what's going to happen is the gap is going to increase between the haves and the have-nots. When we say haves and have-nots, we talk about how much money you have and how much you don't have. Then it will become who has AI and who doesn't have AI, and the power is going to be in their hands. Right? So I think this is a very difficult problem. I don't know whether the human race is capable of answering this creating a solution for this problem, which is why Jeffrey Hinton and a lot of other people are talking about the fear associated with this technology. But the fear cannot be answered by hiding your face and not seeing the fear, like an ostrich does, right? They put their head in the sand and don't see it. We have to see it, and we have to work with it ethically. That's the only solution. And to be fair, it's not really a solution, right? Because we know human beings are not very ethical as such.
Yes, sir. Thank you for your insights on the topic. And yeah, ethics is not something we can trust our human race upon. It's very true. We have seen that through, like you said, nuclear weapons and other things as well. So I think these are the most asked questions that we had right now.
Thank you.
We are close to wrapping up the session for today. Do you have anything that you want to say to us?
My only ask is, do a favor on yourself. You can enjoy life later. Now you've got to skill up. And every minute that you spend not skilling up is reducing your chances of being impactful on the economy. And if we look at China and how it is galloping ahead with AI, if you look at all the innovation that is happening in other countries, the truth of the matter is India is lagging behind. And if we fall into this trap of spending hours scrolling Instagram reels, really, we are never going to be competitive. So my request to you is, think about this as investing in your own future. Investing in your future means investing in the future of the country, right? And so with one single thought in mind, spend time skilling up. All right, so that's my last set of words. Thank you very much. It's been wonderful interacting with all of you, and I hope that we'll get chances to interact further. Take care.
We hope so too, sir, and thank you for the session.
Thank you.
Thank you, sir.
Thank you, sir.
Everyone wait for a while.